Hello learners, welcome to this tutorial on addressing modes of 8051 microcontroller. Addressing modes are nothing but the CPU is going to access the data during the execution of an instruction. How it goes to access those data, or the format of accessing the data during the instruction execution process is termed as an addressing mode. Or in other words, we can say it as the methodology in which the CPU is going to access the data during the execution of an instruction. So we have three different types of instruction. One is 1-byte instruction, 2-byte instruction, and few 3-byte instructions are also available in your 8051 microcontroller. Usually the opcodes which define the functionality of the instruction are 8-bit long. So since it is 8 bits, so we have 2 power 8, we can have up to 256 different functionalities can be defined. Out of this 256 possibilities, we have about 255 opcodes are implemented in your 8051. So out of this 255 opcodes, 64 opcodes are 1-byte instructions. If I assume a clock frequency of 12 megahertz, it is internally divided by 12, so thereby it becomes 1 megahertz. In terms of time, it is nothing but 1 microsecond. So this 1-byte opcodes or 1-byte instructions take just 1 microsecond to execute. So rest of the instructions are 2 microseconds, and the multiplication and division instructions takes about 4 microseconds to execute. So there are 6 different types of addressing modes or methodology in which the CPU will access the data during the instruction execution. So immediate addressing mode, register addressing mode, direct addressing mode, register indirect addressing mode, indexed addressing mode, and implied addressing mode. In immediate addressing mode, the data required for the CPU is available in the instruction itself. In register addressing mode, the instruction contains an register which contains a data. Whereas in case of a direct addressing mode, the address of the data or the RAM memory address is provided in the instruction itself. In register indirect addressing mode, the register contains an address pointing to a data. In case of an indexed addressing mode, we can use an offset value, and this offset value can be added with the base address to generate the physical address of the data. In case of an implied addressing modes, there are instructions which has some default registers to be used. Whenever we use those instructions, certain registers are by default it will be utilized. So such type of addressing modes are called as implied addressing mode. So we will look at this addressing modes one by one with an example. First we start with immediate addressing mode. As I said, in immediate addressing mode, the required data by the CPU is available in the instruction itself. So in the instruction itself, we will have the data. So some of the examples are given here. Move A, hash 0AF. H represents it's an hexadecimal data. So hash represents it's an immediate addressing mode. So whenever we have a data where the MSB nibble is going to be in terms of A to F, we have to add 0 to it. So what we do essentially here, we try to move AF into accumulator. In the second instruction, move R3, hash 45, we move 45 to R3 register. In case of move DPTR, hash FE00, a 16-bit data is moved onto your data pointer. This hash symbol indicates the data in your instruction itself. Second addressing mode is your register addressing mode. In register addressing mode, the source or destination data should be present in a register. Either a source or a destination data should be available in the register. So the registers can be R0 to R7. So we have 32 registers which are divided into banks. Bank 0, bank 1, bank 2, bank 3. Each bank is going to be of 8 bytes, which contains registers from R0 to R7. So some of the examples in your register addressing mode are move A, R5, which means I am going to move a data from register R5 to accumulator. Same way in the second instruction, move R0, A, we are going to move a data from accumulator to R0. In 8051, there are no instruction like move R5, R7, which means I can't move a data from R7 to R5, but the same functionality can be done in a different way. If I want to move data from R7, instead of using it as a R7, I can give the RAM address of R7. If we operate in bank 0, then I can use R5 and R7. So one I can use it as a R5, another register I can use it as an address location. So R7 address is nothing but 7. So like that we can able to write the instruction move R5, 07. So 07 means it is nothing but R7. We can't use it directly as R5, R7. Instead of that we can use it like this, move R5, 07. So where the data from 07 RAM location will be moved on to your R5. Same way we can also do it like this, move 05, R7. So the R7 content goes to the address location 05. An important thing to note here is both the registers should be in the same bank. Next addressing mode is your direct addressing mode. In direct addressing mode, the source or destination address is specified by using an 8-bit address in the instruction. The RAM usually it will be of 128 bytes. So in order to access a data in a RAM, we need to have a 7-bit address. So we use an 8-bit address specified in the instruction to specify the source or destination data in the RAM memory. So here in direct addressing mode, we try to use the internal data memory, RAM memory. And some of the examples are given here. Move 80H, R6. So the register content R6 goes to your 80. So 80 is an address. So address of port 0. So R6 data goes to port 0. In the second instruction, move R2, 45. So the data in 45 memory location goes to your R2 register. Same way in the third instruction, move R0, 05. So we try to move from RAM location 05, which is nothing but R5. The data goes to your R0. So this is how we can make use of a direct addressing mode. Next addressing mode is your register indirect addressing mode. Now in this addressing mode, the instruction contains a register, but this register is not going to have the data. It is going to have the address pointing to a data. So the source or destination address is given in the register. So here we can use both internal memory as well as external memory, and the registers which we can use in the instruction are R0 and R1. If we have a 8-bit address, that 8-bit address can be stored in your R0 and R1. Other registers from R2 to R7 cannot be used for storing the address. Only R0 and R1 can be utilized. In case of a 16-bit address, we use a data pointer. In case of a 16-bit address, we use a data pointer. So some of the examples are given here. So move 0E5H, at R0. So this at symbol indicates now my R0 register contains an address. That address is pointing to a data. So we need to go to that address and take the data, and the data is going to go to E5 memory location in RAM memory. In the second instruction, move at R1, 80. So 80 is an address for your port 0. So from port 0 we are going to read the data and move it to the address location specified in R1 register. So if we move the port 0 data to the address pointed by your R1 register. Next addressing mode is your, in case of a external, in same register indirect addressing mode, we can access the external memory through these instructions. Move X, where this X represents, we are going to utilize an external data memory. So move X A comma at R1. So the R1 contains an address, and from that address we take the data, move it on to your A. So now this R1 as an address pointing to the external data memory. Same way move X at DPTR comma A. So the accumulator content goes to the address location pointed by your data pointer. Next addressing mode is your indexed addressing mode. In indexed addressing mode, the source memory can only be accessed from program memory. So we are going to access the data stored in a program memory. So the destination operand always should be an accumulator. So some of the examples in indexed addressing mode are move C A comma at A plus PC. C represents, we are going to access a code memory. We are going to access a code memory or code byte. So we have an accumulator, and this content is added with your program counter. So it generates an address. So from that address we take the data, move it on to your accumulator. For example, if my accumulator contains 30H, my program counter value is 1125H. So what we essentially do is we add these two values, 30H plus 1125H, so it becomes 1155. In this 1155 address location we have some data. So that data is moved to your accumulator. Same way in the second example, move C A comma at A plus DPTR. Now the DPTR is a 16-bit address. This address is added with accumulator. It generates a new address, and from that new address the data is picked up and it is moved on to your accumulator. So this type of addressing mode is called as indexed addressing mode. And the last type of addressing mode is your implied addressing mode. Mostly in implied addressing mode we will have a single operand. So here for an instruction the register is specified by default. We need not specify it exclusively. By default we use some registers for a particular instruction. That is why it is called as implied addressing mode. It's a register specific instruction. So some of the examples are RLA. RLA stands for rotate left the accumulator content. So here when I use this instruction, accumulator will be used by default. Same way swap A, we are going to swap the nibble content in A register. So here also by default we are going to make use of accumulator content. So by using certain instructions, certain registers will be used by default. So that is given by your implied addressing. So here in this tutorial I have discussed about different addressing modes, like immediate addressing mode where the data is specified in the instruction itself, register addressing mode, instruction contains a register having the data, direct addressing mode, instruction contains an address pointing to a data, register indirect addressing mode, instruction contains a register having an address pointing to a data. Then I have indexed addressing mode. In indexed addressing mode we try to have an offset value in accumulator, and this offset value will be added with your base register. So the base register can be a program counter or a data pointer. So by adding this offset value with the base register content we get a new address. From that new address the data can be retrieved, or to that new address the data can be stored. So such type of addressing mode is called as implied addressing mode. Finally, we have an implied addressing mode where the instruction will make use of certain registers by default. It's a register specific instruction. Thanks for watching. Please subscribe for more technical learning. Thank you.